Okay, class. So we're on page 2, doing questions 1 through 9, and they're asking us to determine whether two triangles are congruent using either the side rule or the side angle side rule. So we're going to try to limit our rules to those two, but we know that there are actually a lot more. In question number 1, what I've done here is I've labeled this triangle number 1 and this little triangle here number 2 so that we can see the two triangles that we're trying to compare if they're congruent or not. Now, I've gone ahead and I've marked these two base angles as congruent. The reason I've done that is because triangle ABC, the big triangle, is an isosceles triangle, shown here by these two congruency dashes. And I know that in an isosceles triangle, I know that the two base angles are congruent. Well, if these two base angles are congruent, and this side is congruent to this side, and this angle is congruent to this angle, well then I can say that triangles 1 and 2 are congruent via the angle side angle rule. Okay? The angle side angle rule. Now, is there another way to do this problem? Sure. I also know that segment BD is congruent onto itself, meaning that this side is congruent for both triangles. And here I can see then that I have an angle, I have a side, an angle, and then another side. Again, where I have a matching side, angle, and side. So I can say that these two triangles are congruent by the side, angle, side rule. And that's really what we were looking for. I know they ask us to limit it to side, 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 and side angle side, but we also know that there are other possibilities as well. And no one answer is better than the other. Let's take a look at number 2. Number 2, I know that this side here, or segment EF, is congruent to segment HJ. I also know that segment FG is congruent to segment JK, but I don't have any indication or any proof that EG is in fact congruent to HK. And being that I don't have any proof then, I'm just going to say that no congruency can be determined. Let's take a look at number 3. Number 3, I know that segment EM is congruent to segment PQ. I know that segment EN is congruent to segment PR. And I know that angle N is congruent to angle R. All these parts are corresponding. However, if I look a little bit closer, what I have is an angle, a side, and a side. And we know that there is no angle side rule, or vice versa. We also know that there is no side angle rule. So although these three parts from the triangles are corresponding, the side angle rule doesn't exist, or the angle side rule doesn't exist. So we're just going to say that there is no congruency to be proven between these two triangles. Let's take a look at number 4. At number 4, I can see that all the sides of this triangle match all the sides of this triangle. And if you remember, then if all the sides of one triangle match all the sides of another, I can say that the two triangles are in fact congruent using the side rule. Let's take a look at number 5. They don't really tell me much about number 5. I know that this is a 90-degree angle here, so then I know that this is also a right angle here, because these two angles are supplementary. They make a linear pair. I also know that segment YA is congruent to itself. But all I have is a side between both triangles and an angle between both triangles. And unfortunately, that's not enough to prove congruency. So for number 5, I'm just going to say no. I can't prove any congruency at this time. Number 6, I have an angle, I have a side, an angle, and a side. Over here, I have a side, angle, and a side. These sides are congruent, these angles between the sides are congruent, and these sides are congruent. So then I can say that these two triangles are in fact congruent by the side angle side rule. This side, the angle between, and this side is congruent to this side, the angle between, and that side. Let's take a look at number 7. Number 7, they tell me that these opposite sides are parallel. I have these angles here are congruent, and I know that this side is congruent onto itself. But if you look closely, I have an angle between two sides. I have a side angle side. And if you look closely on, let's label this triangle 1, let's label this triangle 2. So if you look at triangle 1, I have angle side, I have side angle side. And if I look at triangle 2, I have the same side angle side. So I can say that these two triangles are congruent using the side angle side rule. Moving along to number 8, I can see here that this is triangle 1, this is triangle 2. I can see the congruent parts. And I also know that segment PR is congruent onto itself. And if you notice here, these three sides of this triangle are congruent to these three sides of this triangle here. So then I can say that these two triangles are congruent using the side, side, side rule. And finally, number 9 on page 2. Well, again, they tell me that these two sides are congruent. They tell me that these two sides are congruent. And although they don't give it to me, I should know from past experience and from a lot of other questions that these angles here are in fact vertical angles, which are congruent. And if I look here, well, what do I have? I have an angle, a side, and a side. And if you remember, there is no angle side side rule. Again, here I have an angle, a side, and a side. There is no angle side side rule or side side angle. That rule does not help you prove congruency from the Star Wars video that we saw in class. So we're just going to say no to number 9. Now let's take a look at page number 3 on the other side. On page number 3, numbers 1 through 9, they want us to focus using the angle side angle rule or the angle angle side rule. Which you remember, we said this is the only rule that lets you skip something. Are there other possibilities? Sure, but we're going to try to focus on these two. Let's take a look at triangle number 1, at triangles in question number 1 and 2. Well, I have this side congruent to that side. I have this angle congruent to that angle. And unfortunately, they don't give me any more information. And so as of right now, I don't have any information that would help me prove that these two triangles are congruent by any of the rules that we know. So number 1 is going to be no. If we look at number 2, they give me quite a bit of information. They told me that this angle here is congruent to this angle, and that this angle here is congruent to this angle. By the way, if this reminds you of transversals and alternate interior angles, it should. But these would have to be parallel lines in order for that to work. And if this is a parallelogram, which it looks like, well then these would be what? These would be parallel lines. In fact, the fact that I have alternating interior angles lets me know that these two sides out here are in fact parallel. But let's get back to the point. I also know that segment TV is congruent to itself. So if you look here, I have this angle, this side, and this angle, which is identical to this angle, the same side, and this angle. So I can say that these two triangles are congruent using the angle side angle rule. Let's take a look at number 3. Number 3 should look a little bit familiar to one of the previous questions that we did. I know that these angles are corresponding and congruent. I know that this side is corresponding and congruent. And I also know that this is a vertical angle, which are congruent. And if you notice now, what I have is an angle, angle, and a side, or a side, angle, and an angle. If you're reading this triangle, I have an angle, angle, and a side, or a side, angle, angle. And if you remember, angle, angle, side does help you prove congruency. There is an angle, angle, side rule, or a side, angle, angle rule. Let's take a look at number 4. Again, I have matching angles, I have matching sides, and again I have vertical angles, which are congruent. So again, what I have is angle, angle, side, angle, angle, side, or side, angle, angle, side, angle, angle. So again, these two triangles are congruent using the angle, angle, side rule. Looking at number 5, I know that these two sides are congruent. I know that these are vertical angles. But other than that, they don't give me enough information or any more information. So as of right now, I can't prove that these triangles are congruent. So I'm going to say no, because I need at least 3 parts to match. Let's take a look at number 6. Again, I have these matching angles, I have these matching sides, but they give me nothing else. So again, I need at least 3 things to match. They only give me 2 of each, and I can't find anything else on my own for sure. I can't assume that NP is congruent to RS. So again, I'm going to have to reluctantly say no. If I look at number 7, well, this is a little bit different now, because here I have 3 parts in each. I have an angle, side, angle, which matches the exact same angle, side, angle on another triangle. So I know that these 2 triangles are congruent using the angle, side, angle rule. Looking at number 8, well, for number 8, all they give me is that these sides here are congruent. I know that this side here is congruent to itself. Now you might be saying, hey, Mr. C, this looks just like question number 2. And you're right, it does, except they don't give you the alternate interior angles. Now, they can make it a lot easier for us if they told us this. If they told us that these lines are in fact parallel. If these lines are in fact parallel, then this is in fact a transversal. And if this is a transversal, then these angles here are alternating interior angles. And then what I would have is a side, angle, side, congruent to a side, angle, side, which means that these triangles would be congruent using the angle, side, angle rule. Unfortunately, they didn't tell me that these 2 sides are parallel. I'm just assuming it right now. So I wouldn't be 100% sure. The only thing that I can go on is that these 2 sides here are congruent and that I have a parallel, what appears to be a parallelogram.
Yeah, Rhino.
What appears to be a parallelogram. So based upon that,
Got the blood guy coming up, man. He needs some help with getting some of those.
so based upon that, I'm going to take a guess here and say that this is in fact, these 2 triangles are in fact congruent using the angle, side, angle rule.
Where you located right now, Rhino?
And number 9, let's take a look here. Again, I have matching angles, matching sides, and I know that these are vertical angles. So based upon that, I can say that triangle 1 and triangle 2 are congruent using the angle, angle, side rule, angle, angle, side rule. Okay, and we're done on questions. Oh no, wait a minute. We still have questions 12 through 14. Let's take a look at question number 12. Question number 12 is asking, what else must you know to prove that the triangles are congruent for the reasons shown? So they want us to use angle, side, angle to prove that these 2 triangles are congruent. Well, what's missing? Well, we have the matching angles, but the side is missing. So you would need that mark there between the 2 triangles. That would give you this rule here. Let's take a look at number 13. Number 13, they want us to use angle, angle, side. Well, Here I have two angles, and here I have two sides. So I'm going to put an angle here and an opposite angle there. And now I have angle, angle, side. Angle, angle, side. Proving, in fact, that my two triangles are congruent using this rule. And lastly, let's take a look at number 14. What would I need to have angle, side, angle? Well, I know that these are vertical angles automatically. So I got one of the angles. Then I have the sides. And well, now I just need another what? I need another angle. So I could say that angle L is congruent to angle P. So here I have angle side angle congruent to angle side angle. Could I have used these angles here? Could I have used angles M and Q? The answer is no, because let me put an X here. Let me put an X there. Let's pretend that this is the angle I'm using. Well, then what I would have would be what? Would be angle, angle, side. And that's not the rule that they want. They want angle